All right, so we're looking at the example, limit as x approaches 3 of the function 4x minus 12 divided by x squared minus 9. And again, since there is no number up here in the corner, or no sign, right, no negative, no positive, that means we have to check both directions. So we're going to go ahead and do that. So first I'm going to check from the left. And in order to check from the left, set up my number line here. Here's 3, 4, here's 2. So I can start anywhere on the left. I usually like to start right in between the two numbers and then work my way that way. So we start on the left, right? And so I'm going to put together my chart and plug that into my calculator. Right? So in the y equals screen, I'm going to put in the numerator 4x minus 12. You might need to put that in parentheses depending on your calculator. Divided by, again, parentheses, x squared minus 9. And when I do that and I enter in the x column 2.5, 2.75, 2.9, 2.99, 2.999, I get out these results. So if you want to pause here and check this out yourself and verify the same answers. And if we wanted to, let's see, this is actually, right, lots of 7s. 1, 2, right. Those have lots of 7s in them. So that one is actually 6, 6, 6, 7, 7, 7, 7, 9, 6, 2, 9, 9. And similarly, this one is actually also a 7, 3 7s, 9, 6, 3, 2, etc. So the way you can see more digits is to arrow over to the Y column and then highlight the number that you want to take a look at, right? So that's what I did there. And so we start to notice the pattern of the number of 6s, right? Once I get into the 2.9, 2.99, 2.99 ranges, I go from 1 6 to 2 6s to 3 6s. We can imagine or even check for ourselves that this would be the next version we would get. Right? And sure enough, I get 6, 6, 6, 6, 5 7s, 9, 6, 3. Okay? So this, as this is approaching 3 from the left, our output is approaching 6 repeating, 0.6 repeating, which is equivalent to the fraction 2/3. So I just want to do the same thing on the other side. Right? Limit as x approaches 3 from the right. So on the right of 3 is a number like 3.5. And then again, I want to move toward 3 from the right direction. And so now I'm going to do like 3.5, 3.25, 3.1, 3.01, 3.001, etc. in my x column. And we get these sorts of results. Right, so we're starting to see a similar pattern emerge here. A single 6, 2 6s. I should then anticipate a similar behavior here. Right, I'm going to get 3 6s. Right, and so we see the same behavior. So as this is approaching from the right, this is approaching 0.6 repeating, or 2/3. And since these are the same, we can claim that the limit as x approaches 3 of 4x minus 12 divided by x squared minus 9 is 2/3. Okay, so we've got one more. So here we have negative x cubed over x squared minus 25, and we want to see the limit as x approaches 5. So I want to make sure in my calculator I am switching out my previous function. Don't forget to change your function. from the previous example. And so again, I'm going to set up, here's 5, here's 6, here's 4. So from the left, 4.5, I'm going to see what we get there. So x and negative x cubed over x squared minus 25. So we can try 4.5, 4.75, 4.9, 4.99, 4.999 and see what we get. Okay. So I get 19.184, 43.968, 118.84, 1,243.8, and 12,494. We can see that these are getting larger. They're growing without bound. And so, in fact, this is going toward positive infinity, getting larger and larger and larger and larger. So as we approach 5 from the left, we go toward positive infinity. All right, let's check and see what happens on the right. Okay, so again, I'm going to do a quick check here. 4, 5, 6. So from the right, I'm going to start at 5.5 and work my way toward 5. So they're going to get slightly smaller and get closer and closer to 5. And let's see what we get. All right, so now I get negative 31.69, negative 56.47, negative 131.3, negative 1,256, negative 12,506, and now our behavior is that we're going toward negative infinity. Right? So as we approach 5 from the right, we're going toward negative infinity. And since these are not the same, then our answer is does not exist for the limit as x approaches 5 of negative x cubed divided by x squared minus 25.